Hi and welcome to this YouTube channel of AI with Vic. This channel is purely focused in the area of AI, machine learning, deep learning in general. We'll try and connect the area of mathematics, the smaller topics and even the larger topics of mathematics to the area of AI, machine learning and deep learning. So before we even dive into deep learning or any other part of the AI, we need to understand the language AI speaks, the language of numbers, direction, and transformation. It begins with two simple ideas, vectors and scalars. So let's define first scalars. Scalar is a simple number, a single number, or magnitude, if you can say. And examples could include temperature, like 32 degrees centigrade, pixel intensity, like 220, or even a single model neural network weight, like model weight could be simple 0.72. A scalar is a single value. It tells how much but not where. It could represent like as shown here, like temperature, pixel, or model. Like pixel intensity is basically brightness. And also a scalar can be both positive, as in here, or negative. Now let's define vectors. A vector is an ordered list of scalars, has magnitude and direction. So let's take for example here, let's just label this y, y prime, x prime, sorry, x prime and x. Let's just draw a line from here, 3 comma 4 comma 4. This is the origin, and let's call this point as v is equal to 3 comma 4. So a vector is a list of scalars. It points somewhere in space. It has both magnitude and direction. So the way to find out the magnitude is this, 3 square plus 4 square is equal to 5. Basically its length is found using the Pythagorean theorem. We call it the vector's norm or magnitude. Now let's connect it to AI or machine learning or deep learning in general. In AI, a vector represents data, a word, an image, or even a sentence as a point in high dimensional space. As I'm much more connected to the area of NLP, we'll try and understand vectors from the point of NLP. We will also try and understand vector from the area of computer vision also as we go forward. So now here we know that v is equal to 3 comma 4. Let's define v prime now. Let's understand the concept. V prime is equal to 2 cross v, which is equal to 6 comma 8. That means we are basically scaling it 6 comma 8 in the same direction. So we can actually say this scaled vector is equal to scalar cross vector. This is a simple rule. A number scaling a direction lies at the heart of every matrix multiplication and neural layer. Now let's draw some intuition about application of vectors in the area of NLP, like embeddings. Embeddings. So in the area of NLP, a vector can represent words or meanings. By the way, NLP stands for natural language processing, or you can say the area of deep learning or AI, which deals with text data a lot. So let's take for example a word like king, which is represented by this vector 0.8 comma 0.6, queen, which is represented by a vector 0.9 comma 0.5, and apple, which is represented by 0.1 comma 0.9. Now let's see this in a simple graph. This can be y, this can be y prime, this can be x prime, and this can be x. Let's take from here, this is king, this is queen, and this is apple. So as I mentioned here, that in NLP every word is represented by a vector. The direction and angle between these vectors capture meaning. Like words like king and queen, you can say intuitively are very similar to each other, and words like king and apple are not similar to each other. But how do we measure that? The measuring formula is basically using cosine, called cosine similarity, and it's given by cos theta is equal to vector 1 by dot vector 2, or basically dot product, by norm of v1 norm of v2. So basically cosine similarity measures how close two vectors point are in space. Like it's a fundamental operation in AI. Let's switch to VS Code and we'll try and understand this example in detail there. Let's clear this up. So let's see, import NumPy as NP. Let's define the word embeddings, and it could be, I'm using cursor so it recommends me already the code, but we will try and understand this in a very, okay, it's 0.8, or this is 0.8, 0.6 by queen is equal to np dot array 0.9, 0.5, and apple, which can be represented by np dot array 0.1, 0.9. Let's find out, let's also define the cosine similarity. Cosine similarity. And you can see here, return np dot product between a comma b, and by np dot lin alg dot norm, you can say a star np dot lin alg dot norm b, and you have it here. Let's see, print, and that would be cos queen queen. Let's run this and see how does it work out. Let's clear this up. And here we can see that king and queen are actually very related, which intuitively they are. So the similarity between king and queen is close to 1, meaning they are related, and similarity between king and apple is very less, it's very small. So we can say that they are not related, or they are very dissimilar. That's the power of vectors in AI. That which says that numbers capture meaning. So what do we have it here? By the way, I forgot to mention one more thing, that the range of cos theta that we have here lies between -1 to 1, basically meaning towards 1 it's dissimilar, towards 1 it's much more similar. Okay, so Last but not the least, let's revise the concepts that we have been through, like scalar, a single number, kind of a magnitude, a vector that we have defined here, vector, list of scalars having both magnitude and direction, and scalar cross vector that we have here is basically scaling a direction, basically shrinking or growing in a direction. So scalars define scale, vectors define direction, and together they basically let AI represents and compare meaning in numbers. In the next video, we will talk about matrices, and I will also create a separate video for embeddings where we'll go through the code and understand how embeddings work in deep. Thank you. Please like and subscribe the video.